Hello everyone, a warm welcome to all of you, and this is Meena teacher from Maths Misfit. Today's video is all about logarithms, that is the third part, where we will be doing something about common logs, all about the characteristic and the mantissa of common logs. We'll be solving a few simple examples based on these, and also we will be using the properties and laws that we have done in the first video. Okay, so let's go ahead and find out what is characteristic and what is mantissa. The logarithms are all to the base 10. When there is no base given, it is understood to be as 10. Logarithm of any given number consists of two parts, and the two parts are the characteristic and the mantissa. The characteristic is the integral part of a logarithm. So the first thing that we need to do when we are finding out the values of any logs of any numbers, then we have to find the characteristic first. The mantissa is the decimal part of the log of a number. So we talk about the characteristic now. Take the first case. When the number is greater than 1, the characteristic is 1 less than the number of digits to the left of the decimal point in the given number. So I have taken an example where I have given you the number as 234.45 here. Now the number of digits to the left of the decimal is 3. Subtract 1 from it and the characteristic is 2. So now let's take another example. Say I give you a number here. For example, if I give you a number, say 2568.9.1. What will be the characteristic here? I have got 1, 2, 3, 4, 5 digits to the left of the decimal. So the characteristic is going to be 4. Take another example. I have 1.425. I have got just one single digit to the left of the decimal. So in this case, the characteristic is going to be 1 less, that is 0. All right. So whenever you are looking at a number whose log you need to find, the first thing you need to do is find what is the characteristic. All right. Now take the second case. When the number is less than 1, how do we find the characteristic of such a number? We already know that negative numbers and 0 logs are not defined. The characteristic is 1 more than the number of zeros between the decimal point and the first significant digit, but it is in the negative. And we write it as what I have written here. It is read as bar 1. So if I have a number like this, there are 2 zeros after the decimal and the decimal. So you add 1 to this, it becomes 3. We write it as bar 3. So let's take another example. If I have something like this now. I have got 4 zeros here after the decimal, So I add 1 to it. This will become bar 5. Another way to remember, take the decimal itself as 1. Count. So including the decimal, I have 5. Decimal and the number of zeros following it. Let's take another example. The characteristic here will be, say, the decimal and 1 0. So this becomes bar 2. Let's come to the mantissa part. The mantissa is the decimal part of the logarithm of a number. How do we get that? Is we have to refer to what are called as log tables. Now, what are these log tables? They are available, or if you look up any of the books, or specifically you get by itself log tables. Some of the mathematics books and some of the physics books also have log tables at the end of the book. Now, the mantissa has to be referred and got from these log tables. All right. So if you look at what I have given you as an example, log 2 is 0.30103. Now, if you look at this log 2, it is a single digit. So obviously my characteristic is going to be 0. Now, when this log 2 is given, it is understood that it is to the base 10. So what you need to do here is now you need to find the value of log 50. Now remember, if log 2 is given, that means you have to use log 2 somewhere. So I have to convert log 50 so that I can get some value referring to log 2. So very conveniently, I can put this as log of 100 upon 2. All right. You know our property that we have used earlier. This will become log of 100. This is our quotient property minus log 2. Now log of 100, the value is 2. Minus log of 2, the value is given to you, 0.30103. Now you can subtract this and get your answer over here. Options are given to you. So this will be something in 1 point. Only thing is you need to know, if you look at your options, we have 4 options, and since your answer is going to be in 1, definitely you know that it is going to be the B option. So this value comes out to be 1.69897. Now just look at the sum. Another way how to find your answer, even if you don't work out. Sometimes the options are given that way. Log 50. If you find the characteristic of this number, there are 2 digits here, that is 50 here. So characteristic will be 1 less. Obviously your answer will be something in 1 point. Characteristic is 1. So even if you don't work out this sum, you will get your answer very easily. Okay. Now come to the second part, the second sum. What we have here is find the log of 2 raised to 56. Again, a value of log 2 is given. So log of 2 raised to 56 can be written as 56 log 2. Now what property are you using here? Log of a raised to m. Now the base can be anything. The m comes in front. So it becomes log m log a. We know the value of log 2. So this will be 56 into 0.30103. Now you can multiply this and get your answer. So this will be 16.857. And your correct option over here will be the A option. All right. We are given the value of log 2 and log 7. What we need to find is the value of log 2.8. So let's see how we can convert log 2.8. This can be written as log of 28 upon 10, which further I can write it as log of the 28. I'm going to find the factors. So I can take the factors as 4 and 7. Why have I taken 4 and 7? Because I can convert the 4 to 2 and the 7 log is already given to you. So this will be log of 4 plus log of 7 minus log of 10. We are using the laws of quotient and product. Log 4, I can write it as log 2 raised to 2 plus log 7. I will substitute the values in the next step. So this can become 2 into log 2. Now I know the value of log 2 as 0.3010 plus log of 7, 0.845. Log of 10 is 1. This will be 0.6020 plus 0.845 minus 1. So this answer comes out to be, if you work it out, it is 0.477. Now look at your options. We have an option here, 4771, but our answer is 0.477. So our correct option in this case is going to be none of these. Though there is a difference of 1 in the 4th decimal. So if we had a 1 here, then this would have been the correct answer, but we don't have this as 1. So in this case, we should mark B as the correct option. Log of 3 is 0.4771. Log of 7 is again given to you. Now you need to find the log of 23 1/3. So again here, we'll be using our properties. What we need to do, like in the previous sum, we need to convert log of 23 1/3 So the first step we do is convert this 69 and 170 upon 3, which I can put it as log of 7 into 10, the whole thing upon 3. So this comes out to be, using our properties again, this will be log of 7 plus log of 10 minus log 3. Log of 7 value is given to you, that is 0.8451. Log of 10 is 1 and log of 3 is 0.4771. Now you can calculate this and get your answer. So this will be 1.8451 minus 0.4771. Have a look at the options which you have and see which is your correct answer. Okay. In this case, the answer will be 1.368. Calculate this. So the correct option over here is the C option. Log 2 is given to you. Then find the number of digits. Now you need to find the number of digits in 4 raised to 50. So let's take the log of this number. And you'll understand why we are taking the log of this number. 4 log 50 will be nothing but 50 log 4, I can put it as 2 raised to 2. So this will come out to be 100 log 2. The 2 has come here using our property again. Value of log 2 is known to you. So this will be 0.30103 and this comes out to be 30.103. Now have a look at why we have taken the logs. The reason for us to take the log of this number is here. We have got the characteristic as 30. So now if the characteristic is 30, how many digits will be there? The number of digits will be one more. That is 30 plus 1. So number of digits is going to be 31. Correct option is the B option. Okay. Let's go to the next sum. Again, log 3 is given and 1000 raised to n is equal to 3. Then find n. Now, log of 3 is given to you. So, what we have got here is 1000 raised to n is equal to 3. So, let's take logs on both the sides. So, we'll get log 1000 raised to n equal to log 3. Using our property, we'll get n log 1000 equal to, now log of 3, the value is known to you, 0.477. We all know that log of 1000 is 3. So this is a simple linear equation that you have got, and the value of n will be 0.477 divided by 3. So in this case, it will be 0.159. And the correct option is the C one. So why we have taken logs? The question of why to take the logs is because we are given the value of log 3. And since we know the value of log 3, we can easily find n by taking logs on both the sides. So you have got the values of log 2 and log 3. You need to find the value of log 1.5. Similar sum we had done earlier. This can be written as log of 15 upon 10. which further can be simplified as log of 3 upon 2. Use our quotient property. So this will be log of 3 minus log of 2. Both the values you know. 0.4771 minus 0.3010. Obviously, if you look at your answers, you'll see that the A option is the correct one, 1761. Okay, so in this case, our correct option is the A option. Okay, let's go to the next sum. Now, this is a little bit of a tricky sum. So let's see what we have got here. We have got log 5.7 is given to you. We need to find the value of log 57 plus log 0.57 raised to 3 plus log under root 0.57. So if you look at what you need to find, everything is in 57 5.7, something related to the logs that you have already got. So let's take log of 57. Now, using my property, I'll get this as 3 log. Now the 0.57, I am going to convert it and make it 57 upon 100. Plus, under root means it is raised to half. So I can write this as log half. Again 57 upon 100 here for the 0.57. Now using all our properties of logs, this will become log 57 plus 3 log 57 minus 3 log 100. Now the minus comes because there is a division over here. So we are going to use our quotient property here. Okay. Now in the next step, what we get is half into log 57 minus log 100. Okay. So log 57, now you look here. We have got a log 57 here. We have got 3 log 57 here. And we have another log 57. So I will open out the last bracket first. So I have log 57 plus 3 log 57. And then this will become plus half log 57. And I am left with minus 3 log 100. And this will become minus half log 100. So if you look at all these, the values that I have got here now, log 57 plus 3 log 57 plus half log 57. They are all the same value, so they are all like terms. Okay. Now what happens to all these like terms over here? This is a 1 here plus 3 plus half. So this will become 4.5. In other words, I can write it as 9 upon 2 log 57 minus, this is 3.5, so minus 7 upon 2 log 100. I know the value of log 57, so I'm going to put it here. Now remember, this is log 57. So the first thing is you put your characteristic. Mantissa will remain the same as what is given to you over here. Okay, so this will become 1.756 Log of 100 we all know is 2. So this goes here 0.2878 and you'll get 9 8s are 72, 9 7s are 63, 70, 9 8s are 72. Answer will be 0.902. Okay. The correct option here is the A option. Find the number of digits in 4 raised to 10 into 6 raised to 10. Now you are given two values here and the two values that are given are log 2 and log 3. That means we need to use these values in our given sum. Okay. So I'm going to take the logs of 4 raised to 10 into 6 raised to 10, which I can put it as log of 2 raised to 2 into 10. The 4 I have converted. And then 6 I can write as 2 raised to 10 into 3 raised to 10. Now by using our laws of indices for the same base 2 raised to 10. So I'll get this as 2 raised to 20 plus 10 into 3 raised to 10. Now using our product, this will be log of 2 raised to 30 plus log of 3 raised to 10. So this comes to be 30 into log 2 plus 10 into log 3. Now these are the properties that we have already done. We have used the product property and the other property that we are using is log of a raised to m is nothing but m log a. Put the values of log 2 and log 3. So log 2 into 0.3010 plus 10 into 0.4771. So this comes out to be plus 4.771. So what I get here is some 13 point something something, but whatever that value be, we are interested in this. Why? Because we have to find the number of digits. So if the log of this value is 13, so a characteristic is 13 here. So obviously the number of digits will be 14. The correct option will be the B one. Do not forget to like, subscribe and share. Share this with your friends who are all appearing for the competitive exams so that it can help them. We have finished with the entire topic of logarithms. Revise all the three, go through all the three videos so that you can master the topic of logarithms. Okay? See you in my next videos. Bye. Do take good care of yourself.